Hey everyone, we'll be exploring about blockchain and the data layers attacks on blockchain. Starting with a brief introduction about the attacks on blockchain, we'll be further discussing about the data layer and the composition of it. Further, we will be discussing about the two types of attacks on blockchain, and lastly, we'll finish by defense methods we can choose to protect us from these attacks. Owing to the incremental and diverse application of cryptocurrencies, and the continuous development of distributed system technology, blockchain has been broadly used in fintech, smart homes, public health, and intelligent transportation due to its properties of decentralization, collective maintenance, and immutability. Although the dynamism of blockchain abounds in various fields, concerns in terms of network communication interference and privacy leakage are gradually increasing. Because of the lack of reliable attack analysis systems, fully understanding of some attacks on the blockchain, such as mining, network communication, smart contract, and privacy theft attacks, has remained challenging. To make it well structured and understandable, I have classified the attacks into three broad categories. The attack and defense methods of mining pool attacks for blockchain security issues, such as blocks withholding 51% pooling hooping, selfish mining, and fork after withholding attacks. In the attack type consists as excitation. The attack and defense methods of network communication and smart contracts for blockchain security issues, such as distributed denial of service, Sybil, Eclipse, and re-entrancy attacks. In the attack type of the middle protocol, and the attack and defense methods of privacy thefts for blockchain privacy issues such as identity privacy and transaction information attacks in the attack type of application service. In this video, we'll be focusing on the data layer attacks, which are transaction privacy leakage and private key security. Before diving straight into the attacks of data layers, let's first discuss what is a data layer and what it comprises of. Data layer attacks acts as a blockchain data structure and physical storage. The ledger is built using a linked list or Merkle trees of blocks which are encrypted using asymmetric encryption. The data layer consists of data blocks, Merkle trees, and transactions. Blocks are data structures whose purpose is to build bundle sets of transactions and be distributed to all nodes in the network. Blocks are created by miners. Blocks contain a block hedger, which is a metadata that helps us verify the validity of the block. So typically a block metadata contains a version which is the current version of the block structure, privacy block header hash, which is the reference this block's parent block, Merkle root hash, a cryptographic hash of all the transactions included in this block, and the time that this block was created. It also contains n bits, which tells about the difficulty that was used to create the block, and nouns, that is the number used once, a random value that the creator of the block is allowed to manipulate however they choose to. So moving on to the Merkle trees and transactions. The transactions in a blockchain are stored as a part of a tree called as a Merkle tree. Merkle tree summarizes of all the transactions in a block by producing a digital fingerprint of the entire set of transactions, thereby enabling a user to verify whether or not a transaction was included in a block or not. In, in each leaf node is a hash of a transactional data, and each non-leaf node is a hash of its previous hashes. Merkle trees are binary and therefore requires even number of leaf nodes. If the number of transactions is odd, the last hash would be duplicated once to create an even number of leaf nodes. Merkle root summarizes all the data in the related transactions and is stored in the block header. So, a blockchain will thus consist of all the transactions defined by the user as linked together by storing the hash of the previous block, where each block stores the root hash of the Merkle tree where the actual transactions are stored. Transmission of blockchains across a given network is further secured using asymmetric encryption and public-private key pairs. Starting with private key security attacks and identity privacy attack. First, let's discuss about the private key. A private key, also known as a secret key, is a variable in cryptography that is used with an algorithm to encrypt and decrypt data. Secret keys should be shared with the key generator or parties authorized to decrypt the data. While private key encryption can ensure a high level of security, the following key management challenges must be considered. Continual updating. Private keys used in encrypt sensitive data should be changed regularly to minimize exposure uh, should they be leaked or stolen. Recoverability and loss. If an encryption key becomes inaccessible, data encrypted with that key will be unrecoverable and lost. Cryptocurrencies like Bitcoin depend on cryptographic algorithms to generate, store, and exchange digital value. Cryptocurrencies use public key cryptography for creating digital signatures that authenticate value transfers, as well as symmetric encryption to protect the data exchanges. While secret keys are used for symmetric encryption in the cryptocurrency protocols, there is usually a public-private key pair assigned to the cryptocurrency owner to protect their ownership interests. So, public key cryptography is at the core of blockchain technology. Therefore, improper implementation or handling of public key cryptography can cause some serious blockchain security issues. If the key signing is poorly implemented in the blockchain, for instance, using the same key for multiple signings instead of a Merkle tree, it can allow an attacker to obtain your private key from the public key. Having control of a private key basically means owning all the data associated with you in a blockchain. In case of cryptocurrencies, owning all your coins, although the chances of this happening are very less unless you use a really buggy code for a blockchain. The major issue is the improper handling of the private key. For example, storing it in an infected computer, public space, etc. In 2020, around $300 worth of cryptocurrency was hacked because the user left the public key in Evernote. An attacker obtains your privacy information using the connection between the trader's address on the chain and the user's real identity. This type of attack is the private key identity attack. The attacker infers a user's identity by monitoring public data in the global ledger and analyzes related transactions between the addresses. Presently, common identity privacy attack mainly includes the key, replay, and impersonation attacks. So the key attack occurs when an attacker illegally obtains a private key. Key attacks are performed using software and physical methods. In software methods, an attacker uses specific malicious software to obtain private key data from a cryptographic software system to steal the user's privacy information. In physical methods, an attacker directly steals the connection between the user's real identity and the trader's address on the chain and obtains the privacy information of the transaction participants using the transaction associated graph. Replay attack occurs when an attacker intercepts the user's transaction data and sends a packet received by the destination host, thereby damaging the authentication of the user's identity. Because the blockchain generates a private key during the signing process, an attacker combines the private key information to launch a replay attack, thus affecting the signing process of the blockchain. Impersonation attack occurs when the attacker pretends to be a legitimate user to perform unauthorized operations. In the transaction process, an attacker impersonates both parties of the transaction and simulates the exchange to steal privacy information. Once an attacker successfully fakes the identity of the legitimate users, the user's privacy information is greatly threatened. A study proposed a modular framework to obtain users' identity by considering a large amount of open and transparent information on the blockchain. This framework analyzes the transaction information on the blockchain and classifies the address that may belong to the same user in the cluster. Then it attaches an identity to the user using tags and tracks their transaction liquidity. Finally, it obtains the connection between the trader's address on the chain and the user's identity. Another study proposed a method for determining the relationship between the Bitcoin address and the IP address of its owner by considering anonymous nature of Bitcoin exchanges. According to the transaction behavior of a single trader, this method deletes the transaction behavior jointly initiated by multiple traders in the trading information to find the potential owners. Finally, by combining the frequency of each Bitcoin address in each IP address. This method calculates the relationship value between the Bitcoin address and the potential owner and determines the owner of the Bitcoin address based on this relationship value. Now moving to transaction privacy leakages. Another formidable addition to blockchain security vulnerabilities in 2021 is transaction privacy leakage. Users' behavior are traceable on blockchain networks. Therefore, blockchain systems must safeguard transaction privacy for users. Basically, users must assign a private key for every transaction. Normally, transactions are protected by private keys, so the attacker cannot deduce whether the cryptocurrency in different transactions is received by a specified user. However, in Monero, a digital currency, user adds chaff coins when initiating a transaction so that the attacker cannot infer the actual coins being transferred. So you must be wondering, what is Monero and chaff coins? So Monero is a digital currency. Monero transactions do not exactly specify which previous output are being spent. Instead, a list of alternative inputs is being provided, consisting of a real one and a number of chaff coins. A real signature is then used to prove authority to spend from the real one, without revealing which one that is. This has an advantage of obscuring the transaction graph significantly. It also comes at a very high price, as it means validation cannot use a UTXO set based approach and must instead maintain an ever growing database of spent coins to prevent double spending. Coming back to the transaction privacy attack, privacy protection in blockchain is still not very robust. All the transactions do not contain the chaff coins, which lead to the privacy leakage, since the attacker will be able to infer the actual coins in the transaction. Transaction information attack means that the attacker uses the transition diagram to analyze its potential information and obtain the user's transaction privacy. For example, although transaction information is disclosed anonymously, user user using this attack, the attacker can still download all the transaction history of the Bitcoin and analyze the user's associated transaction graph to obtain information on the type and operation behaviors of the user. This attack includes privacy tracking, false data, and information leakage. So in tracking, after obtaining the user's information, an attacker traces the associated transactions and uses based on the transaction relationship graph. A study proposed an improved privacy tracking method for the Bitcoin system. In this method, the attacker extracts a group of addresses from the public log on the chain and obtains the user's privacy information using a clustering algorithm. False data. Another study pointed out that the attacker links different data fragments of the same anonymous user, that is, the user's public key. If the users are de-anonymized, their information can be disclosed and falsified in addition to displacing and impersonating users to perform false transactions. Information leakage. In the blockchain, users can use their public as well as the private transactions. However, all transaction values and the remaining amount of each public key are publicly available. Therefore, the disclosure of users' information cannot be avoided. An earlier study proposed that de-anonymization attack method that associates the pseudonym of the Bitcoin user behind the network address translation with the public IP address of the host generating the transaction, so as to obtain the information of the user who performed the transaction. This attack method involves four steps. Firstly, the attacker obtains a list of servers using a message query. Based on the address information in the network and the list of servers, the attacker creates an anonymous list comprising of the attack targets. The attacker uses other nodes to uniquely identify the client, that is, network address translation or peer behind the firewall in an anonymized list. And lastly, the attacker monitors the transaction information sent by the client using other nodes and obtains the relevant information of the transaction sender based on the data transmitted by the client. To fight from the attacks mentioned, we have few defense mechanisms. DL initially proposed the mixed coin protocol. In this protocol, because the network integrates a large number of users' transactions into a single transaction, attackers are unable to determine the mapping pair of each user in the input and the output. Thus, determining the connection between the input and the output to address the privacy tracking problem is impossible. Based on the Bitcoin mixing protocol, Mixcoin, the paper hides the input address and the output address of any user in the mixing server by using a blind signature scheme and optimizing the public log. Some scholars apply the current mixing mechanism to the field of blockchain security. Some studies have applied the currency mix coin protocol to the blockchain security. A study proposed a safe and efficient Bitcoin mixer obscuro by ensuring the consistency and the integrity of the code and data. The mixture realizes the correct mixing operation and the protection of sensitive data in a trusted execution environment to exclude coin thefts and address link attacks of malicious service providers. In another study, a service currency Dashcoin based on Bitcoin code was proposed. This digital currency uses the coin mixing mechanism. Moreover, it builds a two-layer network comprising a master code node and a miners to realize the mixed coin protocol. In the first layer of the network, miners are mining methods for network security protection. In the second layer of the network, networks bundle transactions in a mix and send them when multiple funds are combined to achieve privacy protection. Although the Mixcoin protocol reduces the attack risk of privacy tracking and defends users' privacy, it allows illegal personnel to conduct money laundering. A study proposed a detection method based on the Mixcoin protocol to detect transactions that involve money laundering schemes in a timely manner. This method decomposes the transaction into multiple sub-transactions and analyzes the input and the output of the transaction. Then it determines the probability of multiple inputs or outputs belonging to the same transaction. Therefore, this method can track money laundering transactions using the mixed coin protocol to determine whether relevant users participate in money laundering transactions. So, the second defense mechanism is zero knowledge proof. The zero knowledge proof was proposed by S. Goldwasser. The zero knowledge proof implies the verifier completes the confirmation of transaction information without providing any valid information. Therefore, it improves the user's privacy protection and solves the problem of information leakage. The zero knowledge proof involves interactive and non-interactive categories. Because a non-interactive zero knowledge proof does not require an interactive process and avoids the possibility of attacker collusion, it is widely used in blockchain. Some studies have applied zero knowledge proof to blockchain security. For example, a study proposed a program for protecting the user's data privacy using the zero knowledge proof to process the user's original data. After the network completes the zero knowledge proof, a smart contract monitors the user's data. Based on the monitor's data deviation, the program verifies the user's behavior and determines whether the relevant data are being tampered with. Another study used the zero knowledge proof to propose a digital currency zero coin by considering the realization of the mixed coin protocol requires the user's complete trust. Zerocoin uses the Zerocoin protocol to break the connection between the individual Bitcoin transactions, thereby preventing the disclosure of the relevant address information of both parties in the transaction. Based on this study, another study proposed a digital currency Zcash to improve the privacy and anonymity of the transactions. The combination of digital currency and zero knowledge proof technology, ZK-SNARK, enables the sender to provide their corresponding assets using mathematics, ensuring that the only user with the view key accesses the transaction information. Then it encrypts the end result to hide the parties and amount on the transaction records and allows miners to verify transactions even when the exact details of the transactions are unknown. Thank you everyone. Hope I have conveyed thoroughly the attacks on data layers. Remember the key learnings of not pasting your private keys in applications from where your data can be leaked, and keep changing keys on frequent basis.